Hello, this lesson we are looking into rate of change in area on the graph. These two topics are probably the closest you can ever get to the A-level maths because in A-level maths these two will come up again with a lot more depth and details. But nevertheless, we are looking at the GCSE version of this. We are going to look at the gradient and the point on the curve, and we're going to interpret the meaning of gradient in different graphs. Then in the second part of lesson, we're going to go through how to estimate area under the curve and interpret meaning of area in different graphs. Okay, right, so here's some starter questions. Have a go at the question, pause the video. When you're ready for the answer, you can press play. Here are the answers. For question 1, to work out a gradient is difference in y over difference in x. So the difference in y is 10 meters, the difference in x is 4 seconds. So 10 divided by 4 is 2.5. If you know about distance time graph, the gradient actually refers to speed. So the unit is meter per second. Okay. For the second question, to work on the area of trapezium, now this is quite important knowing how to work on the area of trapezium because we need this to estimate the area. Now you can break it down into rectangle plus triangle, but if you know the formula for trapezium, why don't you just use it so you can just do it all in one go, right? So 2a, the trapezium is 3 plus 11 times 4 divided by 2, and for 28, for part B, you have to split into a triangle and a trapezium. Okay, so you get 82 centimeters squared. The first part we're going to look into is to find the gradient at a point on a curve. Now, first of all, you have to understand the gradient on different graphs has different meaning. So for distance time graph, when you do m, the difference in y, distance divided by time, you get the speed. But in a velocity time graph, the gradient actually means the acceleration. So it's velocity divided by time. So it's measuring how fast we're speeding up per second. Okay, so gradient and speed, don't get them mixed up. If you forget them, what you can do is you can just do the unit of the y-axis divided by the unit of the x-axis. For example, for the distance time graph, the unit for y-axis is meters divided by second. M divided by s is m over s, which is the unit for speed. That's one way you can remember it. Okay, certainly that's one way I remember it myself. Next bit, to find a gradient at a point on a curve, okay, so follow these 3 steps. First of all, draw a tangent line on the point. Now, a tangent means a straight line passing through that point, touching the graph once, exactly once on that point. So this is a good tangent. This is an off tangent, pun intended. Get it? Well, this is not a good tangent, it's an off tangent because it's passing through the graph twice and also it's not touching the point that we need. Okay, so tangent is the line, straight line that passes through the curve exactly once. All right, like in the pool, swimming pool, or very cold water, you just dip your toe in there and then take it out. It's like that. Okay, right. And then you're gonna make a right angle triangle, something like this maybe. Use a ruler, of course, and then use that triangle to help you work a gradient because that's the difference in y over difference in x. Here's the first example. Okay, you can use a calculator. Estimate the gradient of this journey after 2 seconds. So on the 2 second, okay, so when time is 2, you go up. So that's the point. You need to make a tangent off. Okay, so set up a ruler and draw a straight line, a tangent that only passes through that point. So here's a tangent that I drew. Okay, you can see, I think it's a decent one. It passes through the point, only exactly on that point, and then it come off. Next step, we're going to need to draw a right angle triangle. Now, so pick 2 points, any 2 points that your line of tangent passes through. So perhaps what I'll do is I'll choose these 2 points and make a triangle. So I've chosen these 2 points to make a triangle. Oops. Right. So my difference in y in here would be, so if I look across that point there, that's 42. And this point over is 10,987. So difference in here would be 42 take away 7, which is 35. A difference in x would be from 0 to 3, so difference is 3. So question A. My the gradient would be 35 difference in y over difference in x, which I've got around 11.7 meter per second squared. Okay, so if you got an answer, if you draw a gradient similar in a similar fashion, in a similar way, you should get a similar answer. Shouldn't be too far off from 11.7, maybe around 11 to 12, etc. Okay, question B, let's try another one. Estimate the gradient of this journey after 7 seconds. So I'm going to use a different color. So this time on 7 second, go up and you draw a tangent around that point here. So here's my tangent. It doesn't matter if your tangent is longer or shorter, as long as it's long enough to make a right angle triangle, and that should be fine. Next, you're going to pick 2 points on the line to make a right angle triangle. So I've picked my 2 points in here. So I just need to read off on the y-axis. That's 49. I've got 49 in here. And then this will be, I believe, 31. So 49 take away 31, that would be 18. And for the x-axis, this will be 6, and this will be 9. So difference in is 3 again. So therefore, part B, the gradient will be difference in y, 18 divided by 3. Now, one thing to note is this gradient is negative because it's downward sloping from left to right. So I've put a negative in there. So it's negative 6 meter per second squared. Part C, interpret the meaning that you found on the answer in part A and part B. So what is the meaning of gradient in velocity time graph? It refers to acceleration. Okay, so part A, the gradient will mean the acceleration of 11.7 meters per second squared, and for part C, part B, it will mean a deceleration of 6 meters per second squared. Okay, so the key point is acceleration for positive and deceleration for negative. All right, this time your turn to have a go to estimate the gradient of a curve. Pause the video, have a go at a question. When you're ready for the answer, you can press play. Here are my answers. Question A, I've got 5 meters per second squared, and then for part B, I've got negative 20. Now, I've done this question twice. The second time when I did it, question B, I've got negative 18.3. So if I say if you get around negative 18, 19, 20, 21, that should be okay. Okay. For part C, part A represents acceleration, and part B represents deceleration. You cannot say acceleration of negative 20. It doesn't make sense. You have to say deceleration. Okay. Next, second part of lesson, we are going to look into the area under the curve. We're going to estimate the area under the curve. Okay. The reason we have to estimate is because a curve is not a straight line, so we cannot really use any area of normal shapes we've learned before to work it out. So all we can do is estimate roughly the answer. To estimate area under the curve, we're going to first split the curve into equal strips, usually given by the question, and then you're going to work on the area of each strip there and add them up. Each strip and add them up. Okay. Now for distance time graph, the area has no meaning. The reason being is when you work on the area, think of like a rectangle. You're going to multiply the y-axis by the x-axis. Meter times second is meter second, which there's nothing with this unit. So therefore the area means nothing. However, for velocity time graph, the area will refer to distance, because if you do meter per second of velocity times second of time, cancel out the s's, you get m, which is the unit for distance. Okay. Now the estimate area is an underestimate of the actual area if most strips are under the curve. Well, it makes sense, right? If a curve is like this and you have to estimate it, you will see some gaps in there, and we will talk about that later. This is quite a common question. Usually, exam will ask whether it's estimate or overestimate or underestimate. All right. Example: use 3 strips of equal width to estimate the area under the curve. Now, 3 strips. The time spans from 0 second to 30 seconds. So part A, if we do 30 seconds divided by 3, that means it's 10 seconds per strip, right? Because we've got 3 strips, we have to take account for 30 seconds. That means each strip is 10 seconds. So what we're going to do, we're going to draw a straight line on every 10 seconds, okay, when it hits the graph. So first, when you use a ruler, make sure you use a ruler. Strip 0 to 10, and this one is 20. Okay, so we've got 3 strips. Strip 1, strip 2, and strip 3. Now, first strip, what we're going to do is we are going to draw a line from the end of each strip, the timing of each strip, and make a straight line, make a shape. So the first strip spans from 0 to 10 seconds, so we're going to draw a straight line from 0 to 10. Same with 10 to 20, from 10 to 20, we draw a straight line. And from 20 to 30, we draw another straight line. Now that's why you can see it's an estimate. The reason being is we are only working the area of this triangle, this trapezium, and this triangle. Now you can see some gaps in between the curve and the line we drew, and that's why it's an estimation, okay? Because it does not represent the full area. Whereas if you do A-level maths, you will actually learn the method to work out the area under the curve. Right, let's have a go. Okay, to work out the area of shape 1 is triangle. The base is 10. The height, okay, so the base times height, the height is 48. So the height is 48. Base times height divided by 2, that's 240. 2 is a trapezium, and hence I gave you the starter question, similar starter question, just to prep you for this. This time, the A value is 48. The B value in here, let me read across, is... Actually, I made a mistake in part A. I forgot to read the increments of the y-axis. It's actually every 2 per square. So that would have been a 46. So that would have been a 46. My bad. So that would have been a 46. So let's rub it off. 46. 46, 230. This one would have been 46 as well. And this time, this will be, if I read across, that'll be 32. So 32. So what about the height of a trapezium? That's 10. So A plus B times height divided by 2 is 390. Number 3 is another triangle. The base is 10. The height is 32. We can use the previous one, 32. So 32 times 10 divided by 2 is 160. Therefore, the total area equals to, add them all up, 230 plus 390 plus 160. That would have been 780. Units, we know it's about the distance, so the unit will be meters. Okay. Question B, interpret the meaning of the area. We found part A, I just said it. So the area represents the distance traveled. So part B, and let me use a different color. Okay, so part B, the area under a velocity time graph represents the distance traveled. If you want to be a bit extra,
what are you?
An idiot sandwich.
Idiot sandwich what?
An idiot sandwich, Chef Ramsay.
You can say traveled in the first 30 seconds. Okay. Question C is on top. Is the area an overestimation or an underestimation? Well, if you look at the area that we made, the shapes that we made, you can see the area we made is actually under the graph. So if it's under the graph, it's an underestimate because most strips are under the curve. The area we found have not accounted for the gaps in there. So part C, the answer, I'll just put in here. Part C, the answer is the area is an underestimate because most strips are under the curve. So the area underestimate because most strips are under the curve. Well, underestimate under the curve. All right. Practice question 2. Okay, this time it's about estimating the area under the curve. Pause the video, have a go with the question. When you're ready for the answer, you can press play. Here are the answers. Question 1. Now, whether you want to use 1 or 1.5 for the height is up to you. Okay, if you got 1, you should get 0.5 in here instead. I use 1.5 to be slightly a bit more accurate. Well, so I got my area, total area is 26.5 meters, which represent the distance traveled. Okay, And then for part B, it's an overestimate because you can see the strips that we drew are actually over the curve. Well, how do you know? You can see the curve is actually under the strip. So that gap means we're overestimating the area. Here is the final practice question. This time a mix of both the gradient and the area on the graph. So pause the video, have a go at the question. When you're ready for the answer, you can press play. Question A, to estimate the acceleration, it means we have to find a gradient. We have to draw a tangent line and estimate the gradient. Now, this is the second time I've done it. The first time I've done it was I got 15.4, but this time I got 17.5. So you could see there's a bit of range of an answer you can get. If I say if you got around 15, 16ish to 20ish, I think that should be okay. As long as your tangent does not go through the curve twice, right? Question B, to work on the distance traveled in 4 hours for 4 strips means you have to split into 4 strips, 1 per hour. So strip 1, sorry, I forgot to mention strip 2, strip 3, and strip 4. So now for strip 1, you can start with the 40 in here, not from the 0, because the curve starts from 40. Okay, so for 40 to 67, etc., you can read the actual numbers for each shape. Shape 2 looks like a rectangle, but actually is a trapezium. Okay, so I've got 216 for the final distance traveled. Unit is kilometers, because kilometers per hour. And then part C is an underestimate, because all of the strips that we drew are under the curve.